Hello and welcome back to Earth's Changing Climate. It is April 15th, and this is lesson 1.3, Exploring Energy in the Earth System. Hey, yesterday we were in 1.2, and one of the main things from yesterday we were looking at is a trend versus a fluctuation, and what the differences are there. Where we saw a trend is something that's more of a long-term pattern that we see happening and emerging, whereas a fluctuation is just a small change in that pattern. The fluctuation might be something where if you're like zoomed in really close, you might not see the whole big picture, whereas the trend is if you zoom out, you'd be like, oh, okay, wow, look at what it's doing. Yesterday, we were looking at melting ice. We were looking at how ice has been decreasing. The trend is that ice has been decreasing on Earth for a long period of time. But if you just zoom in on like a certain period of time, maybe it actually increased for, I don't know, 5 years. If all you were looking at is that 5 years, you would say, oh my gosh, ice is growing like crazy. We're entering a new ice age. But if you zoom out and you see the trend, you say, oh no, wait, that was just for 5 years. Look at the last 100 years. Ice has been decreasing a lot. So trend versus fluctuation, important concept. Hey, our unit question, what causes climate change? We're figuring out a lot about that. We're going to keep exploring that. Our chapter question right here, why is the ice on Earth's surface melting? You're actually going to write a claim about that today. Our investigation question today, here's our question. What could be causing ice to melt and temperatures to increase on Earth? We have a new key concept today, right down here. Global average temperature increases when energy absorbed by the surface increases. Wonder what that means. We've got a whole mess of vocabulary words over here. Some of them you've seen before in previous units. Absorb, climate, energy, model, claim, climate change, evidence, and temperature. So be sure you're looking those up in your glossary if you need to. But let's go ahead and jump right into the lesson. Where's my reading? Here it is. I have it. 1.3. Here is our introduction. Oh, did you do your homework? Did you read about climate change? Were you surprised by maybe some of those effects of climate change? What were they? One of them was it affects habitat of organisms by changing temperature, by changing the amount of water that and the amount of ice that there is. Oh, look, polar bear, the poster child of climate change. Am I right? The habitat change, warming, and sea level rise. There was a nice little graph in there as well showing us how sea levels have risen and what are the implications of that. And then also extreme weather and how we are predicting and we're seeing that certain weather events are going to get more intense and more often. I'm looking for a word. Somebody can tell me later. Sorry. Now, let's go ahead and read the introduction, lesson 1.3, Exploring Energy in the Earth System. How do climatologists study climate change? It's a good question. Today, you will use a digital tool, Earth's Changing Climate Simulation, to investigate ideas about the relationship between energy in the Earth system and temperature. That's the big thing. Investigating the relationship between energy in the Earth system and temperature. What is the relationship there? You'll look at a claim about why Earth's temperature is rising, and then get to spend time making your own claims. How fun. I wonder if we get to do a craft project. Here we go. Let's go ahead and take a look at the lesson right here. Oh, that's a simulation preview. And let's jump into the warm-up. Oh, look at that. 1.3. Nice picture. I like the art that Amplify does. Here is, oh, look, snow. Some of you may have never actually even seen snow before. For those of you who haven't, snow is frozen water that falls from the sky. And look, there's some snow. It says this snow fell during the night and is now starting to melt. Ooh, why do you think this snow is melting during the day? Not rocket science here, people. I'm pretty sure you probably have a pretty good idea. But how about this question too? What does energy have to do with ice melting? So that's actually two questions, right? Why is it melting during the day? What does energy have to do with ice melting? Try to come up with a good explanation for that. We've talked a lot about energy in our class up to this point. So you should have something to say about energy and ice melting. But yeah, go ahead and take a moment to do that. Go ahead and hit pause right now. I'm gonna hit pause too. So how'd you do? Energy, ice melting. Hey, didn't we say before when something goes from a gas to a liquid, you have to take energy away from that gas in order for it to become a liquid. And then when something goes from a liquid like water, liquid water, to a solid like snow, you have to take away even more energy for that to happen. Did you say anything like that in your explanation? Good. I knew you would. Hey, next, let's move to the sim. Check this out. Got a nice simulation here. Here's your mission. Here's your mission. You need to make ice melt. Now, if you're at home, you'd probably have a really good idea of how to do that. I can make ice melt. I'm really good at it. But in the simulation, let's take a look at it. Actually, here it is. Ooh, look at this. There's all sorts of little yellow arrows and these things. Oh, look, sunlight. I can change. I love it when I can change the sunlight gases in the atmosphere. Nitrogen dioxide. I didn't even know that was a gas in the atmosphere. Crazy. So you can change all of these different things. All these sliders are reflectivity. Ooh, look, low, medium, high. Great play up here. We can make the simulation go. We can speed it up, and then we can reset it. Oh, and it says make sure you're in the Earth system mode, which we are. Ooh, human activities. I want to click on that. That's not what I'm supposed to do, but I really want to. Don't worry, you'll be able to do that eventually. We have all this information up here: time, global average temperature, energy entered, energy exited. Hey, I'll bet these are going to be important. Ooh, look, this white stuff. I'll bet that's ice. I'll bet that's what that's representing. And then non-ice, right? All this other stuff down here. The surface, nice, that's labeled. Outer space and our atmosphere. Cool. So what you're going to do, you're going to try to get all of that ice to melt. So what are you going to do? You probably, I'm going to guess, a lot of you are probably going to turn off the sunlight. But what about these gases and reflectivity? Maybe you'll toggle some of those and see if you can get that ice to melt. When you do, oh shoot, yeah, I have the book because I'm archaic. You are doing this online. And let's go to not two. Is it three? Three. Yeah, right there, right here. It says take a screenshot. Don't worry about taking a screenshot, okay? Don't waste your time. Just make the ice melt. But do answer these questions right here. How did the global average temperature change when you made the ice melt? So you got to pay attention to that. And how did the energy absorbed by the surface change when you made the ice melt? So please do answer those two questions. So go ahead and take some time, play around with the simulation, make that ice melt, answer those questions, and then come back when you're done. So go ahead and hit pause. Great. How do we do? You make a bunch of ice melt, sea levels rise. Hey, let's talk about this really quick and let's go over it. How did the global average temperature change when you made the ice melt? You probably could have guessed this already, that the temperature is going to increase in order to get that ice to melt. What about the second question? How did the energy absorbed by the surface change when you made the ice melt? We should have noticed that the energy absorbed by the surface also increased. So we can make a connection there that the more energy that's absorbed by the surface of the Earth, the higher the global temperatures. Yeah. Hey, test it out more in the sim. See if that holds true. But for now, let's go ahead and move on. Ooh, it's where you get to create your own claim. Hey, here's how we're going to do this. You are going to write a claim that answers or addresses this question right here. Why is the ice on Earth's surface melting? Here's how I want you to do it. I created a question in the assignment today. I want you to answer that question. Why do you think the ice on Earth's surface is melting? And then it says, because you're supposed to do this in groups, but we're improvising. Choose the strongest claim. Write it at the top of your ice melting claim student sheet. What is that? I attached it to your assignment. Here it is. It's a Google drawing. So what I want you to do is write a claim here. Now, here's the thing. You can't use your own. Oh, but mine's the best. I know it is. It's so good. But what I want you to do is I want you to use someone else's claim. So go through everyone else's answers on that question. Choose one that you like. Put it up there at the top of the ice melting claim sheet. Make sure you write the person's name somewhere up there too, and your name. And then draw a diagram. Hey, your diagram could look something similar to what you saw in the simulation. It could look entirely different. But draw a diagram showing that claim and why you think the ice on Earth's surface is melting, something that demonstrates the claim that you chose. Okay, so once you do that, make sure you hand it in, and I think after that, I think we're done, people. That's it. That's it. So we did the warm up. We played with the sim a little bit, and then we came up with a claim about why the ice on our surface is melting. Mr. Wiggin, is there any homework? It's all homework. Anyways, hey, see you guys tomorrow. Good luck with that, and yeah, I can't wait to see what kind of claims you come up with.